In today's lesson, we are going to go over lesson 1.2, solving linear equations. The lesson essential question is, how do you create equations and use them to solve problems? So this is going to be the overall question that you should be asking when we go over these examples. The I can statement is, I can create and solve linear equations with one variable. Please notice that this is the same learning target that we have been doing. It's just worded a little bit different. Now, the lesson overview goes over the model and discuss example 1 and example 2. These are the two examples that we are going to go over today, and then you will be doing the try-its. Now, for example 2, I am going to do an extra example to help you with the try-it. So when you look back at this lesson, I'm giving you one more example that is not included in this online textbook, just because I knew you would need some help to complete the try-it.
Hi, this is Mrs. Kerr giving you a video on how to solve example 1 from 1.2. So it says, what is the value of x in the equation 2 times the quantity x plus 4 divided by 3, then minus 8 equals 32. Now you're going to realize that there are different ways or different methods to solve this problem. And that's really the case a lot in Algebra 1. So I'm going to teach you 2 different routes or 2 different methods to do this problem. So method 1 gets rid of the fraction right away. So I know some of you guys don't like fractions, which I don't blame you, but you just need to remember a fraction is just division. So the fraction goes away in this method. And I guess I should say that it goes away first. Okay, so we have 2 times the quantity x plus 4, all divided by 3, minus 8 equals 32. Now, when solving an equation like this, you need to remember that it's all the inverse of operations. So the opposite of adding is subtracting. The opposite of multiplying is division, and vice versa. So when I say vice versa, that means the opposite of minus 8 is adding 8, or adding 8, then minus 8. So just the opposite. So in method 1, the fraction goes away first. And how we do that is that if you see we have this division by 3. So the inverse operation of dividing is multiplying. So whatever you do to one side, so we're going to multiply by 3, you have to do to the other side. Now the other side means the side of the equal sign. There's a left side and there's a right side. So in middle school, hopefully they taught you to draw a line so you can actually visualize. If you want to do that, fine. If you don't, totally cool too. So notice that this 3 right here is in the denominator, and then the 3 that we're multiplying by is now in the numerator. Make sure that you draw it in the numerator, because this 3 right here that I keep highlighting is really in the denominator. So 3 times, this is really 1/3. They go away because 3 times 1/3 is actually 1. So we're left with 2 parentheses x plus 4. So what we did right there was get rid of the fraction. But you cannot forget to distribute that 3 times negative 8, which is minus 24. So we took care of the left side. Now we have to do this part right here. 32 times 3 is 96. And now you can add 24 to both sides, because the opposite of minusing is adding. So that goes away. 96 plus 24 is 120. Now you can actually distribute this 2 as well. 2 times x is 2x. 2 times 4 is a positive 8. And now you have a 2-step. So that's 112. You have 2x, drop down that 2. So then 112 divided by 2 is 56. Now, method 2, and you don't have to do both ways. As long as your work is nice and organized like this, where each step has whatever you do to the left, you do to the right, we are fine with. Now, method 2, you see that minus 8 on the left-hand side? We take care of that first, which is just fine. So then we add 8 to both sides. Like I said, draw that wall if you need to. I'm not dealing with this fraction yet, okay? You don't want to yet. So 2 times the quantity x plus 4, all divided by 3, equals 40. Now notice in method 1, we took care of the fraction first. Well, now we're taking care of the fraction second. It's going to be the same, actually. So we are dividing by 3. The opposite, or the inverse operation of dividing by 3, is multiplying by 3. So whatever you do to the left, you have to do to the right. Now, those 3's just go away, because what that's happening is like 3 times 1/3. 3 times 1/3 just becomes 1. What's 1 times 2? It's just 2. Now, the next step, there's really a multiplying here. So it's 2 times the quantity x plus 4. What we can do is divide by 2. Then we have x plus 4. We no longer need those parentheses because there's only a 1 in front. And now we have the opposite of adding 4, which is minus 4. X equals 56. Notice, no matter which route you went, which method you chose, you would get the same answer as x equals 56.
Now, in the part of the video that you just watched, I was doing this problem on a separate screen. The reason why is because my video programming, my video recorder, Screencastify, doesn't write very well when I'm in the textbook. So you'll notice that sometimes I will go back and screenshot a problem and then just handwrite it. So you can actually get to the problem by lesson 1.2, lesson overview, example 1. And it actually walks you through what I just did. So here's the problem that we just did. If you click the solution, it will show you the steps. Now, I personally think video is better than step, but if you can read and decipher what they did, that's fine too. So it says each solving method yields the same solution. Is one method better than the other? So that's a personal preference. Either method 1 or method 2 will be fine. if you look at how the expression on the left of the original equation is built up from x goes to x plus 4. Then if you build it up, 2 times the quantity x plus 4, and then 2 times the quantity x plus 4 divided by 3, and then the last part is just minus 8, you can notice how method 2 applies these steps in reverse to isolate the x. This is often a good strategy and can lead to simpler solution methods. So once again, it's up to you. So new vocabulary. Remember, variable is an unknown quantity, and that quantity can vary. So what that means is x can be 56 for this problem, but then the next problem it could be 22. It just depends on the actual problem. An equation is a mathematical statement with two expressions set equal to each other. So just remember, an equation needs an equal sign. And then, of course, a solution of the equation is a value for the variable that makes the equation a true statement. So what that means is if I plug 56 back in to the x, then I would get the answer B32 equals 32, which is a true statement. So for your turn, our book calls it a try it. You would want to click this little circle to go to page 2. So you are going to solve the equation 4 plus the fraction 3x minus 1 all over 2 equals 9. Explain the reasons why you chose your solution method. So just like example 1, you now are going to try it showing the steps. Are you going to choose method 1 or are you going to choose method 2? Please show your work on your lined piece of paper, and then you can resume this video as soon as you are done. In this example, we are going to solve a word problem. It says solve consecutive integer problems. So in this problem, it says the sum of 3 consecutive integers is 132. What are the 3 integers? Now you just need to remember a few vocabulary words. The word sum means that we're adding. Consecutive means they happen in a row. Integers means that they can be positive or negative. And the word is going to mean the word equal. So the study tip that is given, it says you can check the solution by substituting the value in the original equation, which we can do as soon as we solve it. So I'm going to move to my OneNote, my notebook, so I can actually write on my screen. So I like to use the guess method. The guess method stands for given, the unknown, equation, solve, and then sentence. So the reason why I call it the guess method is because it actually spells out the word guess. G-U-E-S and then S. So the given is just what information is in the word problem. So we know that we're going to do the sum, which is adding. So we're annotating. We know that we're going to have 3 numbers. We know that the word is means equals, and that it's going to equal 132. So we're going to have 3 numbers, or 3 unknowns for right now. Now, the first number is going to be our x. That's our first number, because we don't know what it is. Is it going to be 5? Is it going to be 30? Is it going to be 94? Who knows? That's what we're going to find out. But we do know that they're consecutive, that they happen in a row. So just in general, let's say I wanted to pick 4, 5, and 6. The reason why I just pick 4, 5, and 6 is that there's 3 numbers and they happen in a row. 5 comes after 4, 6 comes after 5. They're in a row. So let's say I made x equals to 4. Now what would I have to do to get to 5? You would have to add 1. Because, 4 plus 1 is 5. Now if we go from 4 all the way to 6, 4 plus 2 gets us 6. So then it's x plus 2. Now, 4 plus 5 plus 6, that's nowhere near 132. But the cool thing is, these numbers are interchangeable as long as they are consecutive. Let's say I pick 9, 10, and 11. Let's do this. 9 plus what gets you 10? Hey, it's 1. 9 plus what gets you 11? Oh, it's 2. So that pattern, the x plus 1, x plus 2, is always going to work with 3 consecutive numbers. So we know our second number is going to be x plus 1. And then our third number is going to be x plus 2. And we know that because it's a pattern, because they said in this problem 3 consecutive. So it happens in a row. The only difference between the numbers that I just made up and the numbers that go with this problem is this equals 132. So that is where the equation comes in. We know that it has to equal 132. The problem told us that. So then we have our unknown. We have our x. And then notice right here it says sum plus our second number, which is x plus 1. And then plus our third number, which is x plus 2. Now those parentheses really are not needed. It's just to kind of show you that the x represents the first number, x plus 1 represents the second number, and the x plus 2 represents the third. So if you do not like those parentheses, please, by all means, remove them. Now it becomes a problem where you have to combine like terms. We have 1x here, plus another x, plus another x. So total, we have 3 x's. Now we have just a number plus 1 and just a number plus 2. 1 plus 2 is plus 3. And then drop down the 132. And now it becomes a 2-step problem, just like we did last week. So we're going to draw the wall, minus 3 on both sides. We're going to get 129, drop down the 3x, divide by 3, divide by 3. And notice that equation and solve really go underneath the same column. So then 129 divided by 3 gets you 43. Now that is just the first number. You could plug it into the x's, but let's just use some common knowledge. We said consecutive integers. So if 43 is the first number, then 44 is going to be the second, and 45 is going to be the next. 43, 44, 44 comes right after 43, 45 comes right after 44. Now how you can check all of these to make sure you have the right combination is 43 plus 44 plus 45. Does that get you back to the 132? So let's do it. 43 plus 44 plus 45. Yes, it does get us to the 132. So in your sentence, you could write the 3 consecutive integers are 43, 44, and 45. Now, in your book, I'm going to switch my screen again. It just talks about writing an equation to model the problem and then solve. It says the 3 consecutive integers are consecutive, so each is 1 greater than the previous. So notice they started with just the x, and then they added 1 to it, and then they added 1 more, and now they had a 2-step equation as well, because they combine like terms. I minus 3 underneath the 3, but they like to do it horizontally, which is fine. It's a friendly 2-step. You get x equals 43. So the first of the 3 consecutive numbers is 43. And then you just kind of fill in the second and the third. Now, instead of going to the your turn or the try it, I have one more extra example to give you that will help you. Now, this one is not in your book. This is just because I know you're going to need some extra assistance. This type of example is when it says odd or even. So you got to make sure odd and even are the same way, and then consecutive is its own way. So I'm going to start off with the guess method. So once again, we have the word sum. Once again, we're dealing with 3 numbers. I'm going to write the word odd, because that's going to matter. And then is negative 219. Now that negative sign really doesn't mean anything, so don't worry about that too much. Let's go on to the unknown. Unknown, you're going to have the first number be the x. But this is where you have to be careful. If you have an odd number, let's say 5, and then 7, and then 9, these are consecutive odd numbers. They skip the even. They skip the 6. They skip the 8. Let's just make x be 5. How do I get to the next odd number? You do that by adding 2. And then how do you get 5 to be 9? Hey, you add 4. So x plus 4. Now the reason why I say this is going to be the case for odd and even is because you're always skipping a number with odd and even problems. So the second number is x plus 2. And then the third number is x plus 4. Now for the equation and solve, we're just adding the first number plus the second number plus the third number. And we were told that it equals negative 219. Now, one thing that I want to note, yes, it says odd, but that is not going to change the plus 2 or the plus 4. I understand those are even numbers, but we're looking for an odd answer. So that plus 2 plus 4 will always be there for odd integers. Now, once again, you do not need those parentheses. And then let's combine like terms. We have an x there, another x, and another x. So we have 3 x's. We have a plus 2, a plus 4. That gets us plus 6. Now we have negative 219. We have to take away 6. And that's going to get us negative 225. Divide by 3. Negative 225 divided by 3 gets us negative 75. Awesome. Notice that I said awesome because we have an odd number. That's exactly what we're looking for. Now, because it's negative, you have to be careful here. The next odd number is actually going to be negative 73 because we're working backwards. And then negative 71. The reason you can check your answer, negative 75 plus negative 73 plus negative 71, gets us to the 219. If you thought it was negative 77 going that direction, if you checked your answer, it would get you a different number than negative 219. Now, your turn, or the try it, is going to be easier because it doesn't have a negative. So let's go back to that screen. And it's also easier because it's a smaller number. It's 57. It says the sum of 3 consecutive odd integers is 57. What are the 3 integers? So you are going to show work like I did in this example. It's going to ask you for the unknowns, and then you are going to build an equation based on the unknowns. Once you do that, make sure that you are adding 2 to your x. Negative 75 plus 2 got me this answer. Negative 73 plus 2 got me this answer. So you are going to do the exact same thing for your try it. If you have any questions, make sure that you email me. So once you are done with example 1, the try it, example 2, the bonus example 2, and the try it, you are going to upload that work to the Schoology page underneath the assignment for 921. All right, thanks everybody.